What we often do is I'm a very empirical type of person. I like to actually measure my standards and go off of those. So we have several ones here that are, you can see here, I have calcium fluoride. Let's see if I remember how to do this here. Chromium, oops, chromium. You notice we can do multiple selection here. Iron, KCl, manganese, our friend nickel. I think, oh yeah, zinc telluride. Oh, don't forget titanium. There we go. So here's several good friends of ours. Those are all our fun ones. And I can say open to all of those. This opens all of them into tabs here. This is our first time opening more than one file at a time. But now you can see we've opened up all these files together here. And you can easily now say, look at one and say that I'm going to pick the total counts channel just so that there's something in every one. And you can step through all of these and see them all. Now you're going to notice that we have some bad pixels and some good pixels, right? So what are we going to do with this? So the first thing we want to do is do that right click to get rid of the bad row on the left side. Now that would be fine to do if I was only had one file open at a time. But now that I have like more than one, I'd be annoyed to have to go through all my files and do that with. So we're going to do a little diversion into workflows here real quick. So there are these lovely things called workflows. There's a few standard ones that I have in here that are immediately helpful. We'll go into how to edit those later on. And I really hope that as people do more of this, we'll be more interested in creating workflows, and they are easily savable and shareable. And so as we get into processes, I'd like to actually have a whole area where we save workflows and share them with the community to do different things. Big fan of these. There's one here called edge removal. And what this will do is go through all the data files and did edge removal. So now if I click on, we're here at zinc, and I click on ICR, it did the edge removal for us already. And now all these have been edge removed. It's slightly better, but there's still a warm-up pixel, a little bit of warm-up, still one pixel that I don't like on the left there. And there's also some bad spots on the edge. But c'est la vie, that's unfortunate. So it just means we need to do a little bit more work. So what I want to do with all these is create a mask that is the good area. So what we're going to do now is we are going to go through and unfortunately do this manually, but we're going to pick an area that has the most consistent area. I wish we had a better way of doing this for this data set, but we don't. So what I'm going to do is use Shift and pick a uniform area in the middle. Now, unfortunately, calcium's the worst since it has very low signal. But here I go, and I made that mask area. So we create a mask. And I'm going to come here and say, process. Create new channel from mask. I use the shift. We'll call this ROI. So that's one. Now, the other thing we could do, if we were lazier like me sometimes, you might say, okay, I don't want to worry about that. I'm just going to come to this one and click on the window first. I'm going to do a second edge removal and even do one more edge removal. Now I've gotten rid of the bad pixels on the side and only have the good pixels in the middle. And so now for this one, I'm going to go to Process, and I am going to create a mask from the zoom. So this takes my zoom level right here, creates the mask, and then I can create a new channel from mask I'm going to be very careful to call this the exact same thing I called the last one. So ROI. There we go. If I ignore and I say clear zoom, what does it look like? I'm on the ROI channel. Nice full square. So if I like square bits here, I could do this process repeatedly here, go to the copper. And now I could even say, rather than using shift, I could just zoom quickly like this. All depends on what you feel is easier to do for you. I can create a mask from the zoom and create a new channel from the mask. ROI. Iron. Doesn't have any copper in it. That's good. Yeah, little things that matter. Here we'll do it the shift way. Shift, 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 shift. There we go. Of course, this hit it right behind my zoom thing down below here. I'm going to click on mask and just call it a mask. There we go. Process. Create new channel from mask. ROI. Halfway there. Mask from zoom. New channel from mask. ROI. Manganese. Take a look at the manganese channel. This one's got a particularly ugly blemish in the middle here, so we'll choose this side here. Again, mask from zoom. New channel from mask. And ROI. We're almost there. That looks horrible. Let's see what nickel looks like. There we go. Here I'm just going to be even lazier and just do edge removal 2 times. There we go. Mask from zoom. New channel from mask. Go to titanium. There we go. That's another one I can just do 2 edge removals on. One more. There, yep. There we go. Again, I'm just going to do another edge removal. Now, in a perfect world, we would have had nice, clean data sets, and we could have gone into the workflow and said, create an ROI mask from edge removal, and it would have done the edge removal, used the new zoom as a mask, done the mask, created the channel all in one fell swoop. Unfortunately, these particular set of standards were not conducive to that, so we had to do it the really old-fashioned way. So apologize for that part, but at least we're done with that now. So now we have an ROI channel on every sample. Beautiful. Great. So now I believe it's under analyze and under quantification. There was an old way to do this, and that's still under the legacy portion. We're going to use the new one here. So the first thing we want to do typically is look at the editor for the standard calibrants. Here we would normally tell SMAK, oops, if I can find my mouse, what we have as standards, right? So typically you can create a new one if you had a unique one here, but we're going to load the standard. And this particular one should be right here, our SSRL multiple element standard. So we'll take a look at that. And what does this tell us? This tells us that we're using the thin film holder. It tells us what the matrix is, a lovely description, the standard thin film holder in the SSRL multiple entry standard here. And then we have all the different elements that are on that standard, what row and column they're on, and what their elements are that are present, and what their concentration is. But we also have this now as a standard file that you can download when you leave the Beamline. It gives you all those numbers, and you don't have to bother typing them in by yourself. So again, I highly recommend that you copy this file. Now you have it for all posterity until we stop using the standard in your data sets here. If you did have your own custom bits, we can talk about that later, but you can fill out the information of what elements are present, where they're located. So this is a multiple element one, so it has a whole bunch of different ones, and all with the value for that particular element. Okay, so how do we actually use this in practice? So here we are with all of our data sets. I'm making sure that I'm on the ROI channel. I'm going to go to Analyze and Quantification. And now we're going to do a quantitative calibration. So we want to calibrate the quantitative editors. And we'll probably bring up a window that's also too big for everyone to see. But we'll take a look and see how it looks. So I'm going to pull it up here. Hopefully the scroll bars are the whole window this time, not just the, yeah. I did it right once, okay. Actually, I need to do one more thing before I bring this up again. Because we are doing this in multiple files, under quantification here, I'm going to use multi-file definitions. So it's under Analyze, Quantification, and multi-file. If you leave it at single file, it would only work on the one file that you're currently in. But we did all this to look at everything at once. If you remember before when you were in the old, for anyone who had use of the old-fashioned legacy one, you'd quantify everyone individually, and it was a long, arduous process. This tries to make it faster and more streamlined. So I'm going to say use multi-file, and go to this, do this again. Quantification, quantitative here, and it's going to, again, hide it in the back window for me. You can see now, though, that it went through and went to every file and found ROI1 in every file that I had open. This is nice because you can load up, if you have single measurements for every single element, you can look at all these at once immediately, rather than have to do it one at a time. So we need to tell what we want to do. Well, I want to use all of these. And so I can say, let's select all of these. And it puts little X's by everyone. You can try to select them individually, but usually if you're doing this, you're going to use all of them at once. So I've selected all of them. And now I need to tell what file belongs to, what standard belongs to which ROI. So I'm going to link these selections. And now, this is now where I choose the calibration file that I have. If you had made your own, you would choose your own here. Otherwise, you can use this handy dandy one. There we go. Yep, and now I get another window that's down over here again. There we go. And now it's a matter of just saying, okay, this calcium fluoride file belongs to a calcium fluoride standard. The chromium belongs to the chromium. And rinse and repeat. This is going by position on the holders or the position that you've made them in the file. So you have to really be careful and hunt and peck and find the right ones. Oops. And if you mess it up, you can make sure you get the right one. Otherwise, it would be really weird. Now, luckily in the, oops, two things are wrong here. Luckily, in that standard definition file, I actually went through and calculated from the molar ratios of these weird bimetallic ones, bielemental ones, what they are. So you don't have to do extra math. That's all done in that first step. So now we've told what file corresponds to which standard. We'll do this again when we have a single file from, say, beamline 7.2. On 2.3, like this data is, you measure each little one individually because the holder is huge. On 7.2, we just get lazy because we have a big beam size to measure the whole darn thing. So here you would zoom in, create an ROI for ROI1, ROI2, ROI zinc. So you create like 5 different ROIs right away, and then process it in the single file mode. Same thing, multi-file, single file, it all works out the same process. We say okay, it's great. Now it's made the link here. Now we're going to do a single calibration because these are single point calibrations that are highly reliable, of course. So we have basically a 0 and a single point. Our new system will have a multi-point calibration, so we'll have multiple concentrations, so you'll do multi eventually on this. For now, we're doing single, but we're flexible enough to do both. So if you have a mass spec data, you might have a whole series of mass spec concentrations you might calibrate with, so you'd use the multi-calib. We say set up single, and it populates this area over here. Here, we're gonna say, if I wanted to do normalization to an I0 or a time, I could select that. I'm not gonna do it in this case, because it's done at the exact same time. Now I need to go through and tell it that the calcium fluoride standard has these parts to it and what channel in the data does it correspond to that map. I've already gone through and tried to self-select against fluoride, for instance, because we never can measure fluoride since it's below our detectors. So you might just go through here and say, okay, yeah, I'm not going to calibrate the sulfur here in this case since I was at 2.3. I'm going to scroll this window over here so I can access the scroll bars here. Sulfur, I'm not going to worry about. I can worry about those. I didn't measure tellurium, so I'm going to take out the telluride. And then I'm going to go through and say suggest matches. And that goes through anything that's checked and tries to find the data name of the file and tries to match it. I got tired of clicking every darn menu constantly. So there's a few things I try to save your tendinitis for. If it can't find a good match, it'll leave it blank and you'll have to go through and manually do it. So here, yep, it didn't find chlorine because we didn't collect a chlorine channel. So now I say, okay, just don't use it then. Okay, what else? Did everything come through? That's fine, everything is good, okay? So now we say calibrate single, and here it's come through. And now it's a 2-point calibration, so it goes through 0 and 1 point, so the intercepts are all 0. Amazingly, the R squared is a 1 for a 2-point line. So it's a great fit for every single one. Now it's total. Now the slope relationship between counts and concentration. And there we go. We've now calibrated our thing. If we had multiple plots, it would show you the lovely multi-plot correlation. So we can't wait to see how well that's going to work. It'll be great. But now we can save a calibration file. So we hit save here. And this is going to save it in here. This is the calibration data, the QPM extension. And I'm going to say, I think I might have done this once, so I'm going to say new here, so we know it's the best one possible. So now you've calibrated your data from that particular run. Now, I highly recommend that if you care about concentrations, that you run some set of foils every single time you run, because this will be highly dependent on the distance that the detector is from the sample, the incident energy of the beam, everything. So one calibration does not fit all. It's best for the run you're using. You can try to make all the calculations back and forth, but the more you do, the sketchier your data will get. So highly recommend that you go through this process and do it properly. Okay, so now we're done with this. We're all good. The JSON file that we loaded initially is good anytime. That just has the concentrations of the foils.
Okay.
The file we just saved is really applicable to that session only. So now I'm going to come here and I'm going to close all of these since we're done with them. Close all files. I'm really not excited about those ROIs, so I'm just going to discard all those ROIs. And now we're going to open our Jasper Ridge data again. Section 1, HDF. There we go. And here I have iron. And I'm going to edge remove one more time again. And now I can go to Analyze and Quantification, and I can say Do Quantify. When I do that, it asks me for channels first, and that's down here. So what do I want to quantify? Let's do iron, zinc, copper, all my friends. Oops. I'm going to come down to here, and then I'm going to remove sulfur. Oh no. How do I do this? Come on, one at a time. Not that one. Control. There we go. Darn it. Don't listen to what I do. One more time. Iron, zinc, copper, potassium. Don't think I had arsenic, so I won't choose arsenic. Okay, there we go. Okay. And now here's my lovely data file that we just saved. Data new. Open that. And it pulls up the correlate. And now again, it tries to figure out names for you again, so you don't have to select options. If you've done something to your data, maybe blurred it or something, you may need to select down and readjust it. But it's good to do this early on in any case, so that your data files will match. We hit OK, and it's already done. And now you have new channels that are your elements, and it takes the unit from the calibration file. So if these foils were all done in micrograms per centimeter squared. Now it does it in micrograms per centimeter squared. If you had ppm units or anything else, mass units, you could use those. And so now we can go through, and now you see that it looks basically the same. It doesn't really change the dynamics. But now your units here, instead of in counts, iron here was in counts before, now iron's in micrograms per centimeter squared. And zinc, everyone else. And there we go. You have now expressed your maps in units of some sort of concentration. Now, these foils are area ones, and so we did that calibration based on the average signal in that area. We're going to go through another example later on where you may want to look at concentration in the total concentration in an area. And when we do our new set of dots, we'll be doing total. So that's just another option in the calibration. We say, instead of the average, do it on the total ROI, all the counts in the sum of the ROI, which is, again, another way of doing it. If you have, say, a drop of something on a sample, you want to know the concentration in the entire drop, you don't care about the average one, you care about the total sum. So you know, because you know your bond that you deposited on.